Next up for our probability unit, we're going to look at two-way tables. This is another visual diagram, just like our Venn diagrams, and there's a lot of similarities between the two. We're still looking at two different things, which is why it's called a two-way table. So a two-way table is a table that organizes data for two different variables. So for this example, we've got Democrat versus Republican across the top, and then other, and then male and female down the side. So we're comparing, the gender versus the way that people align themselves as far as parties. Okay, one thing that you will need to do if it is not given to you already in your table is add a column and a row for totals. All right, so we need to add this in this case because it's not given to us. So all we're going to do is add down, 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 and then across, across, and then put our grand total. So 46 plus 58 is 104. 62 and 43 is 105. And 22 and 9 is 31. 46 plus 62 plus 22, all the way across, gives us 130. 58, 43, and 9 gives us 110. And then we can double check to make sure we're right. So 130 and 110 is going to give us 240. And then if I go this way, I should also get 240, which 104 and 105 is 209, and 31 gives us 240. So we're going to go ahead and add in those totals because that's going to come in handy whenever we're finding our probabilities. Now this number in the bottom right, this 240, that's my grand total of people that were surveyed or included in this data set here. So there are 240 total people. The totals going down the side over here means that there's 130 males total, 110 females, and then if we go down the side, we have 104 total Democrats, 105 for Republicans, and 31 that classify themselves as other. So that's what our totals are going to represent. If we look individually at these numbers, so like this 62, that is the number of males that are Republicans. Right? The 9, that's the number of females that are classified as other. Right? So that's just how you read the two-way table. So for the next one, we've got a table filled in for us with the number of pets and then the freshman, sophomore, and junior class status. It's missing that totals column and row, so we're going to add that in. So we got total and total. So if I add going straight down, 1, 29, 14, and 5, and 1, that's going to give me 50. Then if I add going down here, 5, 22, 19, 4, and 0, also going to give me 50. And then 32, 11, 6, and 1, and 0, again, is 50. So we've got 50 freshmen, 50 sophomores, and 50 juniors. Now I'm going to do the same thing going across the side. 1, 5, and 32 is going to give me 38. 29, 22, and 11 is going to give me 62. Then we've got 14, 19, and 6, which adds up to 39. 5, 4, and 1, it gives me 10, and 1, 0, and 0 gives me 1. Then I need to add up my grand total. So 38, 62, 39, 10, and 1 gives me 150, which I can easily count 50, 50, and 50 to also get 150. So my grand total of students surveyed in this two-way table is 150. So for number 1, I want to know how many students have no pets. So I'm going to come to the 0 pets line, and I want to find my total. So the total of students with no pets is 38. Then I want to find the probability that a student will not have a pet. So remember, probability is what you want over the total. So what I want is students that do not have a pet, and that's 38. That's what we just found. So we have 38 over, and my grand total, which is 150. There's 150 total students. So 38 divided by 150 gives me 0.253, which we'll write these as percentages. So as a percent, that would be 25.3%. For number 3, how many freshmen have 2 pets? So now I want 2 pets and freshmen. So here's 2 pets, here's my freshman, so that's going to be the 14. And I want the probability that a student will be a freshman with 2 pets. So freshman with 2 pets, that's going to be my 14 over my total 240. All right, so 14 divided by 240 is going to give me a decimal. And my decimal is 0.058, which as a percent becomes 5.8%. Just move your decimal 2 over. Then I want to find the probability that a freshman will have 2 pets. So now I want, out of the freshmen, the chances that they're going to have 2 pets. Well, my total freshmen's 50, so that's going to be the bottom because I know that they're freshmen. And out of those, the ones with 2 pets are 14. So we have 14 out of 50. And when I do 14 divided by 50, I end up with 0.28, which becomes 28%. Right? The difference between these two questions is if number 4 wants to know the chances that the student, so looking at this grand total of 240 students, will be a freshman with 2 pets. So that's 14 2-pet freshmen. All right, then we have the probability that a freshman will have 2 pets. This time, looking for the probability that a freshman, so I've narrowed it down to just a freshman class. I want to know how many of them will have 2 pets, or the probability that someone in the freshman class will have 2 pets. So in that case, my outcomes were different. So my outcomes changed. I went from 240, narrowed it down to 50. So we are going to continue with the same table, but it's already filled in for us. Here's our same totals. I want to know the probability that a student will be a junior with 3 pets. So I want to know the probability that a student, so my grand total is 240, looking at all the students, will be a junior with 3 pets. So here's my juniors, here's my 3-pet juniors. So that's 1 out of 240. Not a lot. So that's 0.004, which is going to be 0.4% when I move my decimal. So very small amount. What's the probability that someone with 3 pets will be a junior? So now it's not probability that a student, now it's probability that someone with 3 pets. So my new outcome becomes a total number of 3 pets. So here's 3 pets, total is 10. And out of that 10, we've got juniors, so 0. 0 out of 10 is 0. So we got 0% chance that someone with 3 pets will be a junior. Then we want to know the difference between the two questions. Again, for the first one, I was looking at the entire student body that we're looking at here, all the freshmen, sophomores, and juniors. For the second one, I want to know how many of the 3 pets are juniors. Right? So again, the outcomes changed. For number 10, what's the probability that a student will be a junior or have 3 pets? Okay, remember, or we add. Okay, so the probability that a student is a junior, okay, we've got our juniors here, so we've got 50 out of 150, and I'm going to write this one down here. So 50 out of 150 plus the probability that they will have 3 pets. So my 3 pets are 10 out of 150. But you could be a junior and have 3 pets. So I do have overlap there, and I counted this one junior twice, so I've got to take him back out. Right, then we just add straight across because I have common denominators. So 50 plus 10 is 60, minus 1 is 59 over 150. And then when we divide, we get 0.39. So we get 0.39, which is going to become 39%. And then for the last one, the probability that a student will have at least 1 pet. So at least 1 pet, let me get rid of this guy here. At least 1 pet means it's going to be including 1, so that's going to be everything below 1 on all of our tables. So I want to add up all of these and put it over 150. All right, so now we've got 29 plus 22 plus 11 plus 14 plus 19 plus 6 plus 5 plus 4 plus 1 plus 1. And then 2 zeros. So we've got 112 over 150, which whenever I divide, I get 0.746. So we'll say 0.75, and so that's 75%. Oops. By just counting, going the wrong way. Oh, goodness. Close enough. All right, by just counting and including all of these, I'm not counting anybody twice. So then that means I don't have to subtract anything. I can just count up everything and put it over my grand total. And the last thing we're going to look at in this video is converting from a two-way table, a regular two-way table, to a frequency table. And basically that just means we're going to write our percents over here. All right, now the only trick is instead of actually putting the percent in, we're going to leave it as a decimal. Okay, well, our grand total, 240 out of 240, that's going to be 100%. It's always going to be 100%, right? That's our max. That's the highest that we can get. But instead of a percent, we're going to put a decimal, so we're going to put 1.00. This will always be your grand total, right? 1.00. To find the rest, all we're going to do is divide the number that we're working with divided by the total. So for the first block of male Democrats, we've got 46 divided by 240, which gives us 0.19. Then we do the females. 58 divided by 240 gives us 0.24. And then you have two options. One, we can go ahead and add 0.19 and 0.24, which would end up giving us 43. So I know this has to be 43. Or you can keep going. 104 divided by 240, which does give you 0.43333 repeating. Okay? Republican males, that would be 62 divided by 240, which is 0.26. 43 divided by 240 gives you 0.18. And then 26 and 18 is going to give us 0.44. And then over here, 22 divided by 240, so a small one, is 0.09. 9 divided by 240 is even smaller. We get 0.04. And then 0.09 and 0.04 is going to give us 0.13. Now you need to double check and make sure that these all add up to 100 or 1. And 43, 44, and 13 does add up to 1. Okay, so then again, I can add these three up to get my total, or do 130 over 240. So if I just add these three up, 19, 26, and 9 gives me 0.54. And then if I add these three up, 24, 18, and 4, that's going to give me 0.46. And 54 and 46 does add up to 1. So all we do to get to a frequency table is take the number divided by the total for all of our blocks. You do need to kind of make sure, double check that your totals are still correct, because everything should still add up going across and going down. Your grand total is always 100% or 1.00.